Hi, welcome to Building Codes Division. The State of Oregon Building Codes Division, or BCD, provides a wide range of services to the public and to Oregon's construction industry. We serve Oregonians by working to ensure safe building construction while promoting a positive business climate within the state. This is the State Code Update Training for the 2023 Oregon Residential Specialty Code, also referred to as the 2023 ORSC. This video is the first of a three-part training resource. A separate video covers Chapter 11, Energy Efficiency Provisions of the 2023 ORSC. The third and last video covers Chapters 12 through 24, Mechanical and Fuel Gas sections. Please see these additional videos to view the complete set of significant changes presented by the Division of the ORSC. All BCD Residential Inspector and Residential Plans Examiner certification holders are required to complete code-related update training, which is provided by the Division. The various certifications that require this training are the Residential Structural Inspector Certification, also known as the CAS, the Residential Plans Examiner Certification, the CAX, the Residential Mechanical Inspector Certification, or CAM, the Specialized Finals Inspector Certification, or SFI, and the Specialized Solar Photovoltaic Certification, the SSI. The objective for this training is to identify the significant technical changes to the structural, fire and life safety, and general design requirements resulting from the adoption of the 2023 ORSC. At the end of the video, Division contact information will be provided, where you may submit any questions or feedback. Up-to-date contact information for each presenter is also available on the Division's website. Information about the new 2023 ORSC, such as code adoption process, codebook availability, and code-related publications, is available on the Division's website on the Codes and Standards webpage. We appreciate your attendance and look forward to working through the updates with you. Here is a brief introduction to the structural technical team members presenting the structural and fire and life safety portions of the training. Tony Rocco is our structural program chief. Eric McMullen is our senior building code specialist. And Jeremy Williams is our structural program engineer. Our presenters for the energy efficiency and mechanical topics are Mark Heiser, our Mechanical and Energy Code Program Chief, and Kelly Thomas, our Energy Policy Analyst. Their introductions are included in a separate training video which covers the energy efficiency, mechanical, and fuel gas sections of the 2023 ORSC. As a reminder, our team is a technical resource for our local government partners and other customers. We are always happy to assist and always appreciate hearing from you. The 2023 ORSC is based on the 2021 International Residential Code, the IRC, with Oregon amendments. For this video, distinct formatting is being used to show the various types of changes. The change summary box highlights the topic covered and provides a brief synopsis. This summary box will identify if the topic is a model code change from the IRC, an Oregon amendment to the IRC, or simply a helpful reminder for a commonly questioned topic where no change has occurred. Where we are highlighting a model code change, we will generally only show the new language added in the 2021 IRC. That language will appear in pink. Where we are highlighting an Oregon amendment, blue underline will denote added language and red strike-through will denote deleted language. For this training video, the division has created a supplementary code adoption summary that includes all Oregon amendments to the 2021 IRC, the significant IRC changes highlighted in this video, and other important information about the new code. The code adoption summary is linked in the video description below, along with the chapter timestamps to aid in navigation through this presentation.
Before we get started on the 2023 ORSC code updates, beginning in Chapter 1, we'll set the stage with the reminders of how critical it is to always consider the scope of a given code prior to jumping into the technical requirements. For the ORSC, the overarching scope and application are detailed by the leading provisions of Chapter 1. Over the past 5 years, our division has worked with our legal counsel, local government partners, OBOA, stakeholders, and other customers to further clarify the administrative provisions of both the OSSC and ORSC. Particularly under the ORSC, national model scope creep had created a significant misalignment from our governing authority and statutory charge. On the next slide, we'll quickly revisit the concept of statutory authority in the context of the ORSC scope. Not all matters included in a nationally promulgated model code are necessarily covered by our statutory authority here in Oregon. This is a key concept to always remember. Just because something is included in the IRC, IBC, or IFC nationally doesn't automatically somehow establish legal authority to regulate that same matter here in Oregon. Oregon revised statutes detail legal authority, not a nationally promulgated code. This image is useful to illustrate those areas which apply statewide under the shall oval, matters which are deferred to local municipalities to consider value added to customers through additional regulation locally in the may oval, and matters which do not fall under the authority delegated to local municipalities by our division, outside both ovals and identified as not regulated under 455. The shall includes reasonable safeguards to occupants and users of buildings, the construction, reconstruction, alteration, and repair of governed buildings, dwellings and occupied buildings operating under a current C of O, affected buildings and related accessibility standards, and other items such as covered multifamily dwellings in alignment with the FHA and tsunami design standards in OSSC Section 1615. The May Oval lists matters which may possibly be regulated locally, where local elected officials and other policymakers determine additional regulation adds value for their communities. These matters must be implemented via local ordinance and must follow applicable statewide construction standards if they are regulated locally. This includes fences other than required swimming pool barriers, freestanding signs, freestanding tanks, flagpoles, and towers, certain ground-mounted PV arrays greater than 10 feet in height, the actual construction of private in-ground swimming pools, the R327 wildfire hazard mitigation standards currently, and small equipment shelters not intended for human occupancy. A comprehensive list of these matters is included starting on page 1 of the code and should be closely reviewed by each municipality. Finally, outside both ovals, we see a number of matters which are completely outside the authority of our State of Oregon Building Codes Division. These matters may not be regulated under the delegated authority from our division and must not be commingled with the funds dedicated to the locally assumed building inspection program. This includes common matters such as demolition, seismic rehabilitation programs for existing dwellings in regulated buildings, post-occupancy lease and rental arrangements such as Airbnb and VRDs, dangerous building ordinances, construction located in the public right-of-way, outdoor equipment, and equipment not specifically governed by the mechanical provisions of the state building code. Where any of these matters are regulated locally, it is entirely independent of our division and the authority we delegate to the local building department. Similarly, here we see many of the same examples in a different format. These lists are not exhaustive, but are provided as a hopefully useful resource for all viewers to refer back to. The actual scope and application of the code details these matters in a list format. Of note, for the may category of considerations, there are specific parameters for many of the items listed. For example, fences 7 feet or less in height cannot be regulated by a building permit anywhere in the state. The purpose here is to establish a threshold of potential value added, and particularly for residential customers, to allow additional flexibility for work to be conducted without additional regulation and oversight via permit. Our best recommendation is to carefully review the list in Chapter 1 of the ORSC and OSSC, discuss any of the permissible may matters with the local policymakers, and become familiar with the matters which are completely bifurcated from the general scope, application, and authority of the ORSC and OSSC. As we move into the first slide listing an ORSC section, we keep the consistent theme going of our overarching scope and application, setting the stage for reviewing these code updates. Looking historically at the original intent and purpose of creation of a dwelling code, it's important to note that it once started out as a collaboration of recommended building practices for places of abode. Fast forwarding to today's modern code, our low-rise dwelling code, which has become our Oregon Residential Specialty Code, is for residential uses in detached 1- and 2-family dwellings and townhouses. In recent years, we have clarified that other dwelling uses, such as day-to-day business operations, are more appropriately addressed by the OSSC. Under the 2023 iteration, live-work units meeting the appropriate OSSC provisions, owner-occupied lodging houses, residential aircraft hangars, and detached 1- and 2-family dwellings and townhouses, and their accessory structures not more than 3 stories above grade, are covered by the scope of the code. Other uses, including congregate living, care facilities, and other licensed facilities, are now addressed more accurately via the OSSC. In some cases, those uses may be permitted to meet the construction standards of the residential code, but the uses are still addressed through the scope and application of the structural code. Here in section R102.4, a concept most often overlooked during the OSSC administration, but one with equal importance under the ORSC, is regarding the extent of reference standard application. Reference standards are only applicable to the specific extent referenced. The majority of the standards referenced in code have provisions which are not applicable to the application of the ORSC. It's important to note how the standard is specifically referenced by code, what topic or citable subject matter is being addressed, and any limitations of a given reference. For example, section R317.1 identifies locations requiring either naturally durable wood or preservative treated wood in accordance with AWPA's U1 standard. In this example, we would only use the U1 standard for identifying preservative treated wood parameters and not for any other portion of the standard. Of course, this is useful as a general recall concept when reviewing either the ORSC or OSSC. Over the past several iterations, our technical team has worked hard to refine the activities listed in section R1052 as exempt from building permit. In prior iterations from years ago, the list even included items which weren't included in the scope of the code, since the list was originally based on the National Model Code. A very common misconception is that if some type of activity isn't on the list, then it must mean that that activity requires a building permit. Wrong. We don't use the list of exempt activities as some type of reverse authority threshold for requiring building permits. Remember, the scope of the code sets the stage for the permitting authority. Under the dwelling code, we also have a governing statute detailing the items which shall be exempt from permit and fees in our state. This reference is ORS 455-310. Building on the improvements already made to Section R105.2, in the 2023 ORSC, we have clarified exemptions number 6 for patio, porch, and deck covers, number 8 for non-bearing partitions, 13 for door and window replacements, and number 15 for membrane-covered frame structures. In number 6, we add deck cover to the list of exempt covers and removed a requirement for them to be supported by an exterior wall. Similar to the common detached non-habitable accessory structure in exemption number 1, these outdoor space covers can either be attached or detached, but not more than 200 square feet in usable area. Regarding non-bearing partitions, we added a clarification regarding these partitions, which are required to be fire resistance rated, such as a demising wall between dwelling units. If the partition requires a fire resistance rating, it is not exempt from a building permit. When considering door and window replacements, the restructured exemption clarifies that window replacements must still meet the hazardous location requirements and minimum U value provisions from code, and that if any structural member is changed, such as a header, or if the door or window is required to be fire resistance rated, then the exemption does not apply. Item number 15 finally has added clarity by the addition of a defined term for membrane-covered frame structure. The original and current intent is to capture those big box store RV and car covers as illustrated above. Having a defined term in Chapter 2 will help narrow the intent of the exemption. Section R202 and our definitions play a critical role in application of the code. Often we overlook highlighting defined term changes during the update training, but for this iteration of the ORSC there are several important changes. Both building area and floor area have been added as long missing defined terms to help clarify the intended limits listed throughout the code. Building area aligns with the definition we know from the OSSC. As we just covered in R105.2, we see the new definition for membrane-covered frame structure to narrow that specific exemption. Most importantly, the definition of accessory structure has been aligned with the National Model Code. In the 2015 iteration of the IRC, the 3,000 square foot and 2-story limitation from the definition was removed. The accessory structure limitation was originally introduced in 2008 and never matched how the code scoped governed buildings. The size and height limits have been removed from the ORSC and no longer limit the size and shape of accessory structures. As we covered in Chapter 1, the code still limits all governed structures to a maximum of 3 stories above grade plane in height, but there is no size or square footage limitation for dwellings or now accessory structures. This common sense model code change underscored that most local land use laws will limit accessory structure size, and that it's not aligned with the overall hierarchy of code to limit square footage. Additionally, since the 3,000 square foot limitation has been removed, Section R328 regarding permissible area increases for accessory structures is no longer necessary. It was a great section that resulted from the hard work from the Rural and Remote Task Force, but it's now not needed since there is no citable limit to an accessory structure's size in the code. This offers great flexibility for Oregonians, particularly in rural areas where larger accessory structures are a necessity. If municipalities wish to limit accessory structure size, it would have to now occur through the land use side of the regulation. Looking at the new version of the definition, aligned more closely with the national model, we see the parameters regarding size have been removed. Additionally, the existing amendment, which identifies various examples of non-habitable accessory structures, has been retained. This list was originally intended to add clarity to the R105.2 exemption number 1 for one-story detached non-habitable accessory structures, particularly for uses such as garages and carports. In recent years, many questions have arisen regarding those uses that don't fit neatly into either the non-habitable or habitable description. Common examples include private offices, art studios, exercise rooms, and similar. The general distinction for habitable space when considering these detached accessory structures is the ambiguous term living. Our team will be taking a closer look at this code inconsistency in the near future and will hopefully arrive at a reasonable solution providing clarification necessary to support predictable statewide application of the exemption for Oregonians.
Hi, this is Jeremy Williams, Structural Program Engineer with the division. I'll be covering some of the structural design related updates in chapters 3 through 6. Section R301.1.3 has been clarified and renamed from Engineer Design to Non-Prescriptive Design. The Code Adoption Advisory Committee recommended changes here to help reduce confusion regarding the trigger, enforcement, and review of designs or portions of designs that fall outside the prescriptive recipes within the ORSC. Non-prescriptive design is now a newly defined term, which includes two types of designs: those that are required to be prepared by a registered design professional, and those that are exempt from that requirement per Oregon's engineering and architecture licensing laws. This section now requires the submission of a non-prescriptive design instead of an engineer design for your review and approval for portions of the project that fall outside the prescriptive provisions of the code. This will make more sense as we look at the new definitions. But before going there, note that the lower portion of this section has been struck. That portion was originally recommended as an Oregon amendment during the 2021 ORSC adoption process to clarify scope and intent, but was recommended that it be removed this cycle because it contradicts the preceding sentence, which allows a design in accordance with the OSSC. Here are the new definitions for non-prescriptive design and engineer design. Non-prescriptive design is defined as the design of structural elements exceeding the limits of Section R301 or otherwise not conforming to the prescriptive provisions of the ORSC. The design shall result in a system capable of supporting the loads prescribed in the ORSC or OSSC and provide a complete load path that transfers those loads from their points of origin through the load-resisting elements and foundation to the supporting soil. A non-prescriptive design is either an engineer design, which is also a newly defined term, or a design not required to be prepared by a registered design professional in accordance with Oregon's architecture and engineering statutes, but deemed adequate by the building official. Engineer design is defined as a design in accordance with accepted engineering practice prepared by a registered design professional. The Code Advisory Committee also recommended revising Section R106.1 submittal documents for clarification and alignment with the changes made to Section R301.1.3. This section no longer lists work that doesn't require a registered design professional and instead directly references the respective architecture and engineering statutes. Know that BCD doesn't interpret those statutes. Also note the model code change you see here in pink. It's a new specific allowance for submitting electronic plans where allowed by your building department. Some of you have been allowing electronic submission for some time now, while others may not have implemented it yet. Reminder that with the passage of House Bill 2415, which was intended to improve statewide consistency for electronic processes for reviewing plans, issuing permits, and performing field inspections, Oregon Administrative Rule 918-050 was amended accordingly and requires all municipalities to have the capability of accepting electronic submission of construction documents by January 1st, 2025. As mentioned previously, BCD does not interpret the Oregon State Board of Engineers and Architects rules and statutes. If you have any questions related to their rules and statutes, our best recommendation is that you reach out to them directly. Here's their contact information for your reference. Here's what you see when you navigate to the Oregon State Board of Examiners for Engineering and Land Surveying website. You can click on their Contact Us section here to get phone number, email, or a staff directory. From their main page, you can click on the Public Resources tab here and see that they have the new 2022 edition reference manual for building officials linked here at the bottom. And here's what you see when you navigate to the Oregon State Board of Architect Examiners website. From their administration hub, you can go to their Contact Us link and email them or call their main line. There's also a staff directory if you want to contact one of these folks. And from their main page, you can go to the resources, publication and reports. And from there, you'll see they also have the link to the latest reference manual for building officials from their website. Same one linked by the OSBIL's website. This reference manual they prepared is a 26-page guide filled with information intended to assist you and the general public in understanding the laws governing the practices of architecture and engineering in Oregon. It's essentially an informal interpretation of their current laws and rules. For example, on page 6 of the manual, they discuss exempt buildings. It states the architecture and engineering laws and rules provide an area where a person who is not registered or as an architect or engineer may plan, design, and supervise the erection, enlargement, or alteration of a building. These buildings are considered exempt. An important thing to note here is that just because a structure is exempt from requiring a registered design professional to do the design, it does not relax the submittal requirements for the proposed construction. You still have clear authority via Chapter 1 of the ORSC to require whatever is necessary, such as design calcs, structural load path construction details, etc., to ascertain code compliance. But know that there is no cited path in Oregon to require a registered design professional for projects that are considered exempt per OSBIL's and OSBAE laws and rules. We now have a direct path in the residential code for shipping containers that are repurposed for use as dwellings or their accessory structures. This new model code language points to Chapter 31 of the OSSC for compliance. Also note the new definition in Chapter 2, which is the same as the OSSC. You may remember that Eric covered Section 3114 when we presented the 2022 OSSC update training last year. It contains both detailed and simplified structural design requirements for the use of the containers depending on application. You no longer need to rely solely on an alternative approval process in accordance with Section R 104.11 for repurposed shipping containers. Last year, BCD hired CPP wind engineering consultants to complete a study of our codified special wind regions and associated basic design wind speeds. The purpose of the study was to update our OSSC and ORSC wind design criteria based on statistical analysis of the most current meteorological data available in accordance with ASC 716. Thanks go out to the Structural Engineers Association of Oregon and Washington for their collaboration and coordination in this effort. As a result of this study, there have been substantial reductions to the basic design wind speeds in our special wind regions. This colored illustration shows the percentage change in wind speeds from the 2021 to the 2023 ORSC in the affected regions. Here's a breakdown of the changes for each affected county in Table R301.2. Also note that the historic footnotes H, I, and J that triggered higher wind speeds at sites with full exposure to the ocean or Columbia River have been struck. The reason you see duplicate wind speeds for some jurisdictions, such as Deschutes County, is that the special wind region map is locked in by ASC 716, which we refer to for site-specific verification of whether you're in or out of the special wind region. Instead of removing special wind regions eliminated by the study, we just lowered those wind speeds to match the non-special wind regions within the county. The Structural Engineers Association of Oregon is taking the information from these CPP wind engineering studies and sharing with ASC 7 for incorporation into ASC 728. So this redundancy in special wind region map cleanup will likely occur in the 2031 OSSC and 2032 ORSC. And here's figure R301.2.1 parenthetical 1. The only changes are the extension of the special wind region in Curry County and the footnotes. Footnote A changes the reference for verifying special wind regions from the Applied Technology Council to the ASC 7 hazard tool, which we'll discuss in a moment. Footnote B clarifies that the new extension of the special wind region is not captured by the ASC 7 hazard tool and notes that the region extends 15 miles inland from the coastline. The reason for the switch from the Applied Technology Council Hazards by Location tool to the ASC 7 hazard tool is because the ATC Hazards by Location tool will no longer be updated for future editions of ASC 7. From the ATC website, they state, with the availability of ASCE's hazard tool in the free domain, we feel there is no longer a unique need for the ATC Hazards by Location website, and ATC will be deferring to ASCE for providing free hazard information to the profession. These same related special wind region wind speed changes were made to Table 1609.3 and Figure 1609.3 as an interim amendment to the 2022 OSSC, so both codes are currently aligned on this subject.
You can find this online tool by reaching the ASCE website or by scanning this QR code.
Here's what you see when you navigate to the ASC 7 Hazard Tool website. First thing you're going to get is this pop-up window, message welcome screen. You can close that. Enter your site address of concern. Here I'm entering one in Mapleton, Oregon. You select the reference standard version ASC 716. Select risk category 2. Toggle on the wind load type and select view results. You see right away it says we're in a special wind region. See details, and we can toggle this overlay under the wind row here to see that we are in the special wind region hatched pattern there. There's no change to the irregular building section of the code to report on, but we're sharing an IRC provision here that wasn't adopted in Oregon in case you see it in an ICC publication or training course and are wondering about it. The 2021 IRC brought in a new regularity trigger for homes on steep hillsides based on a proposal from structural engineers representing FEMA and the Applied Technology Council. This was based on findings of vulnerability of such dwellings in the 1994 Northridge, California earthquake. 117 significantly damaged hillside dwellings were identified in reconnaissance reporting, 15 of which had collapsed, and another 15 were found to be on the verge of collapse. The general concept here is that the different rigidities of variable height cripple walls for crawl spaces taller than 7 feet affect the seismic behavior of the structure beyond the assumed behavior contemplated by the prescriptive lateral provisions provided in the code. The Code Advisory Committee recommended disapproving and deleting this new language because they felt the cost increase associated with the new trigger isn't warranted based on no reported issues or concerns in Oregon on the matter. The ORSC now points directly to our plumbing code for seismic restraint of water heaters. We've had inconsistent provisions in the past due to language in this section in Chapter 13 of the IRC that differed slightly from the charging plumbing code provision. The only related change dimension in Section 507.2 of the 2023 Oregon Plumbing Specialty Code is that the exception was clarified by specifically adding seismic design category B, which was always the intent. And note that the related historic water heater seismic strapping interp number 15-02 is being updated to reference the 2023 OPSC. Within the ground snow load determination section, we've clarified the minimum snow loads for prescriptive and non-prescriptive design as an Oregon amendment. The minimum ground snow load for use with the prescriptive design provisions and associated tables within the ORSC is still 36 PSF, and the minimum roof snow load is 25 PSF, except where the roof snow load is calculated in accordance with Section 1608 of the OSSC. The key word here is calculated. Section 1608 of the OSSC refers the user to Chapter 7 of ASC 716 for roof snow load calculation and sets a minimum roof snow load of 20 PSF plus 5 PSF rain on snow surcharge for roofs less than or equal to 1 unit vertical and 12 units horizontal, or roofs that constrain runoff by parapets or other similar obstructions. Reminder that the only time roof snow load is referenced for design in the ORSC is in Section R802.10.2.1, Applicability Limits for Wood Roof Trusses, which states, for consistent loading of all truss types, roof snow load is to be computed as 0.7 times ground snow load. 0.7 times the 36 PSF ground snow load is equal to 25 PSF roof snow load. A new model code exception in this section conditionally allows wood frame story heights up to 13 feet 7 inches instead of the previous limit of 11 feet 7 inches. To meet this new story height exception, studs greater than 10 feet up to 12 feet in unbraced height have to meet exceptions 2 and 3 of Section R602.3.1, which we'll cover when we get to Chapter 6. The wall bracing for the building needs to comply with Section R602.10, and lateral restraint has to be provided at the bottom and top of the wall by the foundation, floor, ceiling, or roof diaphragm.
A major challenge that each of our local government partners face on a regular basis is deciphering the use of non-technical land use, developer, and real estate terms that don't neatly align with our technical code. Popular terms include condos, triplex, quadplex, cottage, cottage cluster, and even ADU. Unfortunately, none of these popular terms mean anything under application of our technical code. Most often, the structural configuration proposed, along with the stated intended use, will determine the appropriate code application. When considering the ORSC limitations, if we have stacked units and more than a single detached two-family dwelling, which is permitted to be stacked, the project will be regulated by the OSSC. If the proposed configuration meets the townhouse definition, where there are no stacked units, and each dwelling unit is separated from the next, from the foundation to the roof, the project will be regulated under the ORSC. Another proposed configuration becoming more common is having multiple detached dwellings on a single lot. Under the 21 ORSC, clarifications were added to demonstrate what minimum provisions are applicable to this configuration. Assuming land use approved having multiple detached independent dwellings on the lot, the code now clarifies what is required from a code application standpoint. Where multiple detached dwellings are located on a single lot, they must each independently meet the required fire separation distance or associated exterior element fire resistance rating. The charging language in section R302.1 clarifies this requirement and points us to the associated table for each separate dwelling. Additionally, a clarification was added regarding attached decks greater than 30 inches above grade. This clarification is that they are required to be treated as projections for the purposes of Table R302.1 and the exterior wall element protection. Here we see the governing language, associated table, and an illustration of multiple detached dwellings on a single lot. Similar to buildings on the same lot under the OSSC, we simply identify an imaginary line between the dwellings and verify that either minimum required fire separation distance is provided or related exterior wall element fire resistance rating is met. Note the long-standing amendment of reduced minimum fire separation distance from the model code 5 feet is retained in our Oregon-specific 3 feet. In many cases, this minimum distance is superseded by local land use laws and required setbacks for front, side, or backyards. Our historic townhouse provisions of section R302.2 have been retained. Minor, non-technical editorial corrections throughout the section have been made, and in the 2021 iteration of the ORSC, all existing figures were updated and recreated. Our technical team did propose reducing the number of Oregon amendments and aligning more closely with the model IRC regarding townhouses. One possibility was to retain these existing amendments as a statewide alternate method for customers. However, the committee and advisory board elected to retain the existing R302.2 as it existed in prior iterations. Additionally, the base model code included a new provision for detached two-family dwellings and dwelling unit separation. That model code change specified that only a single 1-hour wall was required even where real property lines separated the two units of the detached two-family dwelling. This model code change was disapproved by the committee and board, and our existing language was retained, which provides options for customers proposing this real property line separation and specifying not less than a 2-hour separation in these instances. Another important piece of our code updates is to identify significant model code changes which were disapproved. Many of our local government partners take model code training courses, such as changes to the 21 IRC, as they collect continuing ed credits for renewing their ICC certifications. Occasionally, major changes at the national level are disapproved here in Oregon during promulgation of our specialty codes. Identifying these disapprovals are critical to prevent misapplication of our Oregon codes. Here in section R302.5.1, we see an example of a model disapproval. 2 iterations ago, the model reintroduced the self-closing or spring hinge requirement for the garage-to-dwelling doors. That reintroduction was disapproved and remains disapproved here in Oregon. In the 2021 model, a new provision was added to require that the door not only be self-closing, but it also now be self-latching. This new requirement was also disapproved. As we look at the provision, we see the struck model language at the end of the charging provision in R302.5.1.1. In Oregon, garage-to-dwelling doors can be solid wood, not less than 1 3/8 inches, solid or honeycomb steel, not less than 1 3/8 inches, or 20-minute fire-rated door assemblies. These doors are not required to be self-closing or self-latching. Mark Heiser and Kelly Thomas from our technical team have prepared the companion ORSC trainings for the mechanical and energy provisions and provide additional details about these related ventilation changes. You can locate those trainings on our related web pages where this training was accessed. Here, the model code has updated natural ventilation exceptions for kitchens and other habitable rooms. A local exhaust fan or system is now codified as a design option for kitchens within the exceptions listed, and R303.4 has been clarified as being only applicable to newly constructed dwellings, not additions or reconstruction, and flexibility is added for possible approval of other equivalent means of ventilation. Here we see the reconfigured exceptions to the natural ventilation and operable glazing provisions. First, Exception 1 now applies to habitable rooms other than kitchens. The associated glazing in these rooms is not required to be operable, assuming the window is not required to meet the EERO provisions of Section R310, and where either a whole house ventilation system is provided or where a ventilation system producing 0.35 ACH in the habitable rooms is installed in accordance with the applicable provisions of Chapter 15. Now, new exception number 2 is specific to kitchens. Similarly, the glazing in kitchens is not required to be openable, where it is not required to be an emergency escape and rescue opening, and some type of local exhaust system is installed in accordance with Chapter 15. Parallel to the adjustments in R303.1, we have the change in R303.4. One commonly questioned requirement under the 2021 iteration of the ORSC was regarding the new whole house ventilation system. The intent has always been that the whole house ventilation system is only required for newly constructed dwelling units. It does not apply to any type of addition or to reconstruction of damaged dwelling units. This has been added to the provision for clarification. In addition, design flexibility has been included, permitting other means of ventilation to be approved by the building official in place of the prescriptive whole house ventilation system. Emergency escape and rescue openings, or EEROs, are a major component of ORSC governed safeguards. In the 2023 ORSC, a number of changes have occurred in Section R310, and the next few slides will walk us through those new provisions. This includes the addition of a minimum 36-inch wide path from an enclosed yard or court to a public way, the replacement of the term window well with the more encompassing term area well for those EEROs located below grade, and additional flexibility for basement alterations, additions, and conversions to habitable space. We'll walk through all of these changes one by one. One common question, particularly for townhouse configurations, is regarding egress windows which open directly to an enclosed backyard. The long-standing intent has now been codified for this configuration. In prior iterations, while the intent was for a yard or court to open to a public way, the minimum width of that opening from the enclosed yard or court to the public way was never specified. Under the 23 ORSC, if our ERO opens to an enclosed backyard or court, an unobstructed path not less than 36 inches in width must be provided. This could be via a gate or door in the enclosing fence, for example. Here we see a great example of the 36-inch unobstructed path. We have 4 townhouse units, and in unit number 3 we see that an egress window located at the back of the unit opens to an enclosed backyard. Since our path of escape must ultimately get us out to the public way, the plan shows the new 36-inch wide path to a gate in the enclosing fence, and then to an extension leading us out to the public way. One critical note is that we cannot regulate any portion of an adjacent site or any portions of land outside the site under permit. There may be cases where this unobstructed path is only regulated to the 36-inch wide gate in this example. It will be important to remember this limitation as we identify the path from any enclosed yard out to the public way. Here in section R310.2.4, the new language specifies that when a required EERO is located beneath a porch, deck, cantilever, or similar projection, not only must our unobstructed pathway be not less than 36 inches in height until we get out from under the projection, but it now must be not less than 36 inches in width as well. Think of this as an unobstructed tunnel, 3 feet by 3 feet clear, until we get out from under that deck, porch, cantilever, or similar projection. Here we see that cantilever is added to the title of the section, as well as in the body of the provision, and the new language specifying that 36 inches in width. In the new 2023 ORSC, the term window well has been removed. This has been merged with the term area well. We see the new charging language in section R310.4, as well as the aligned term throughout the subsections. There are no technical changes to the old window well requirements beyond this terminology adjustment. In the 21 iteration of the ORSC, both window well and area well existed. Now in the 23, we only have provisions for area wells. In section R310.6, we now have an additional exception specific to dwelling additions. This exception points to section R310.7.1 as a deemed to comply option for complying with the ERO provisions in the context of an addition. We'll cover the details of R310.7.1 on the next 2 slides, but when considering its application, it's important to note the charging language. The R310.7.1 compliant ERO is permitted for dwelling additions containing new sleeping rooms and for dwelling additions of basement areas. Specific to alterations of existing basements, this new provision clarifies 2 things. First, where a new sleeping room is created in an existing basement, for example, a basement conversion, an ERO is required to be provided in that new sleeping room. And where an existing basement undergoes alterations or repairs, including a basement conversion to habitable space, an emergency escape and rescue opening is not required from the basement area. Similar to the exception added for dwelling additions in the previous slide, this provision has an identical exception permitting the ERO in the converted basement's new sleeping room to meet R310.7.1. Let's take a look at that provision. Here is new subsection R310.7.1. Existing emergency escape and rescue openings. Aside from the two exceptions that we just covered for dwelling additions and new sleeping rooms of an existing basement conversion or alteration, this provision addresses where a change of occupancy or use leads us to the requirement for an ERO. The ERO required is permitted to meet items 1 and 2. This would apply for an existing space undergoing a change of use or occupancy which is not a basement. For example, an existing attic storage space converted to a sleeping room, or an existing den converted to a sleeping room. Even converting an existing garage to a habitable space sleeping room. If the space in question already has an operable window, that window must provide 4 square feet of net clear opening and minimum dimensions of 22 inches in clear height and 20 inches in clear width. If the existing window is being replaced, the replacement window must meet item 1 above, with the net clear opening of 4 square feet and the minimum dimensions noted, and the replacement window must be the window manufacturer's largest standard production window that will fit in the existing rough opening without requiring any structural changes. The window can be a different style than the existing window as long as the overall net clear opening is not reduced. More plainly, similar to many other areas of the code, we simply cannot make the existing ERO any less complying than it was prior to the replacement activity. Here in section R311, several important changes have occurred. First, in subsections R311.7 and 8, we have existing Oregon language retained as well as alignment with new model provisions regarding stairways and ramps which are regulated and those which are not. There are several common nuances to note here. Next, a new model exception has been added regarding exterior landing slopes where the landing must facilitate surface water drainage away from the building. In addition, we've also included a critical reminder from ICC about the bottom landing of exterior stairways that is commonly overlooked. When considering stairways, it's important to make the distinction between regulated stairways and those stairways which are not regulated. In the 2021 ORSC, we included new Oregon language intended to help clarify application of R311.7 throughout the state. Here in the 2023 iteration, that language is further clarified. Stairways which are not regulated by R311.7 include any stairway not within or serving a regulated building, regulated patio, porch, or deck. Any stairway, drop-down ladder, portable ladder, etc. leading to non-habitable attics, such as storage attics, since storage is not habitable space, and any stairways, ladders, steps, etc. leading to crawl spaces, as defined. These are critical nuances to consider. The most common is regarding the bonus truss attic storage space. Assuming the space is for storage only, which is non-habitable, customers can use drop ladders, portable ladders, potentially non-compliant stairs, etc. to access the non-habitable attic. Additionally, ramps not within or serving a regulated building, regulated patio, porch, or regulated deck need not meet the provisions of section R311.8. Under our long-standing stairway walking surface slope limitations, we now see a new model exception here in section R311.7.7. This exception now allows a steeper slope for exterior stairway landings required elsewhere in code to drain surface water from the landing. In these cases, the slope can be as steep as 5% or 1 unit vertical and 20 units horizontal. For a typical 3-foot landing, this means that we could have just over 1 3/4 inches of slope across the 36-inch length. As noted, we also see a long-standing ICC clarification regarding the bottom landing of regulated exterior stairs. This active national interpretation clarifies that the bottom landing of a regulated exterior stairway is permitted to be the ground or a gravel surface as long as the required dimensions and slope are met at the time of final inspection. This is an important option to remember for customers. Nothing is requiring pavers, a slab, pressure-treated wood, or similar. Again, this has been our long-standing understanding of the code's intent, as further supported by ICC's active interp. Here's a great clarification regarding our measurement for determining when window fall protection is required. While we have clarified this measurement several iterations ago for our maximum EERO height above the finished floor, this measurement detail was only delineated previously via interpretation and ICC's stated intent. Now, in section R312, the language clarifies that the measurement is taken from finished floor to the bottom of the clear opening. Another important reminder is that this threshold for requiring fall protection is intentionally different when considering ORSC-governed dwellings and OSSC-governed Group R2 units. The OSSC threshold remains at 36 inches, where our ORSC trigger remains at 24. Here we have a section view and detail of our measurement and other considerations to trigger the fall protection safeguard. The bottom of our clear opening must be at 24 inches or higher above the finished floor, or we must have less than 72 inches of fall to either grade or a flat surface at least 36 inches in width on the exterior side of the window to not need fall protection. Here are 3 quick examples. The bottom of a window clear opening is located at 18 inches above the finished floor, but on the exterior side, grade is only 5 feet below the bottom of the clear opening. No fall protection is required. Next, on the exterior side of the dwelling, our distance from grade to the bottom of the clear opening is 10 feet. However, inside, the bottom of the window's clear opening is at 26 inches above the finished floor. In this example, no fall protection is required. Finally, our window's bottom of the clear opening is located at 18 inches above finished floor, and on the exterior side we have 7 feet to grade. Fall protection in accordance with section R312 is required to protect the occupants.
Section R314, smoke alarms. This change is going to cover a couple of new location requirements for smoke alarms. The first new location is found in section R314.3. This new requirement will require a smoke alarm at the end of a hallway when there is a room with a ceiling height that is at least 24 inches higher than the hallway. In addition, there's a minor Oregon amendment to this new section where bedrooms is struck and replaced with the term sleeping rooms because bedrooms is not a defined term in the ORSC. The next new smoke alarm location requirement is found in section R314.3.1 and is related to proximity to cooking appliances. Items 1 through 3 have not changed. Item 1 requires ionizing type alarms to be installed not less than 20 feet from a permanently installed cooking appliance. Item 2 reduces that distance for ionizing alarms to 10 feet when they are equipped with an alarm silencing switch. And item 3 requires photoelectric type smoke alarms to be installed not less than 6 feet from a permanently installed cooking appliance. The new item 4 now addresses smoke alarms that are specifically listed to help reduce cooking nuisance alarms. These alarms can be installed no closer than 6 feet from a permanently installed cooking appliance and can be either ionizing or photoelectric type. Section R317, protection of wood and wood-based products from decay. The provisions for the protection of wood against decay have not changed significantly for quite a few code editions. So this update accomplishes a much-needed overhaul. There was no intent with the changes to significantly change the technical content, only to clarify the requirements and clean up some errors in syntax and correct some misleading text. Section R317.1. On this slide, we see some changes to items 1, 2, and 3. For item 1, columns were added to give them a required clearance from exposed earth in crawl spaces. This isn't really new. It's generally in conformance with the old exception that was deleted. Item 2 also includes columns, and again, this was to find a home for that requirement due to the deleted sections. And then item 3 is an existing Oregon amendment specifying what can count as an impervious moisture barrier. Section R317.1 continued. Now we move on to items 8 and 9 in the same section. And as you can see here, there's a lot of pink language, which indicates new model code language. For item 8, the language was actually moved from a deleted section, R317.1.3, for geographical areas. This language seemed to require wood members exposed to the weather to be treated or naturally durable only if a need was demonstrated. The code now requires protection as the general rule and provides an exception for drier geographical regions. Note that an Oregon amendment is added to that exception requiring that need to be documented. For number 9, this language was also deleted from section R317.1.4, and this is the language that allows the 1-inch clearance for wood columns with basement concrete slabs. And also an Oregon amendment there clarifying what works as an impervious moisture barrier, or at least an example of what would work. Section R320, accessibility. This change is intended to clarify the accessibility provisions that are specific to live-work units. When we get to section R320.1 here, you can see that there are some amendments there also. Now, those are existing amendments, so no change there. The change is in R320.2, specific to live-work units. And this change is clarifying that the non-residential portion of a live-work unit is subject to accessibility. There's a reference to 508.5.9 and 508.5.11 of the Oregon Structural Specialty Code. 508.5.9 is a general reference to Chapter 11, and 508.5.11 is a reference for accessible plumbing features. There's also additional language that clarifies where there are 4 or more live-work units, the dwelling portion shall comply with Chapter 11 of the Building Code based on the configuration. Section R323, storm shelters. This change includes some new model code language that is deleted and also a new model code definition. In section R323.1, we find part of the related changes. And also just a reminder that this section is existing and it doesn't require storm shelters to be constructed. It does provide some guidance for where storm shelters are constructed and how they are to be constructed. You'll note that the sealed documentation language in red is struck out here. That's the new language that was added to the 2021 IRC. This was struck to align with our Oregon requirements for OSBE and OSBEALs, where a registered design professional is not required. And finally, you can see the new definition that was added for storm shelter. Section R324, Solar Energy Systems. This change is a fairly large one in that it incorporates the previously approved provisions that were found in the OSSC into the ORSC without any technical changes. The rooftop-mounted photovoltaic systems requirements will now be found entirely in Section R324 for those within the scope of the ORSC. This language was brought over unchanged from the structural code previously found in Section 3111. That language is still in the structural code and will be amended as we move forward for that next iteration. No changes in the requirements at this point. Just a couple of reminders that the prescriptive installation application does not apply to manufactured homes, and it's also not required for ag or forest exempt buildings. And don't forget that for prescriptive applications, Form 4910 is required to be submitted. And finally, Tony is going to be talking about the work of an upcoming informal work group that may result in some changes to the prescriptive application, similar to what you find in the state of Washington. Still in Section R324, we're going to talk about some clarifications that have been made to firefighter access and escape requirements. Firefighter access and escape pathways related to rooftop solar can be a little daunting to apply. So recently, the division developed a new technical bulletin intended to clarify and explain the provisions. A link to that bulletin is on this slide, as well as an example of one of the illustrations. The bulletin helps to explain things like what an intersecting adjacent roof is and how to deal with scenarios where there are disconnected attic spaces. Section R324.7, Solar Ready. This change incorporates some of the existing Solar Ready provisions that were found in the 2021 Oregon Residential Reach Code. Section R324.7.2, Solar Ready Construction. So the provisions you see on this slide are new to the ORSC. They were brought in from the 2021 Reach Code. And then all of the existing Solar Ready provisions were moved from Chapter 11, Section N 1107 to 324. For the change you see here, these four exceptions were brought over from the Reach Code, and they allow some variance to whether or not solar ready construction needs to be included. There are provisions for size, provisions for total solar resource fraction. So if there's not enough sun, then it doesn't make sense to put it in, and that term is newly defined as well. Moving on to Section R324.7.3, the only change here to these provisions is a move. These were previously found in the 2021 ORSC, and they were found in Section N 1107.4. These are the interconnection pathway requirements, and they were just simply moved to this section. The final piece to these solar ready provisions is a new requirement that also came from the 2021 Reach Code. And this requirement is for some reserved panel space. There needs to be 2 dual pole circuit breaker spaces reserved, and it needs to be marked reserved for future solar. Still in Chapter 3, now on to Section R327. R327 covers wildfire hazard mitigation, and we're going to talk about some changes to the scoping and some upcoming changes that are going to apply to R327. The primary change to the existing R327 has to do with the scoping provisions. The previous scoping provisions have been deleted and they've been replaced with what you see here in R327.1.1 for local adoption. This allows a local jurisdiction to adopt this section without following the local adoption statute 455.040. There's a few requirements tied to the adoption. The areas that are going to be subject to R327 need to be identified. A transition plan for any subdivisions that are already under development needs to be included, and a local appeals process. And finally, if a municipality had previously adopted Section R327 via local ordinance, then that local ordinance may still continue without any change. The other piece to the local adoption scoping changes is a requirement for notification found in Section R327.1.2. This section requires a local jurisdiction to notify the State of Oregon Building Codes Division and also provide a copy of any locally adopted map showing the areas where R327 is going to apply. The final piece to the R327 discussion is what this looks like moving forward. Many of you are probably familiar with Senate Bill 762 from back in 2021 that was passed by the legislature following the 2020 wildfires. And then in 2023, Senate Bill 762 was revised under Senate Bill 80. And the piece that ties to R327 for these bills is the creation of a wildfire hazard map statewide. And when that map is finished, which is still currently in the works, any homes that are located in areas that are designated as high hazard and also within the wildland urban interface will then be subject to R327. So after the map is finished, there'll be a 6-month grace period before R327 becomes mandatory. And also any local jurisdiction adoption that we discussed in the previous slide or that had previously adopted before the scoping changes, those will be supplanted by this new wildfire hazard map.
In Section R401.2, an Oregon amendment we had in prior iterations has been brought back by recommendation of the Code Advisory Committee and Board. This is the requirement to provide lateral restraint between the bottom of the foundation wall and top of footing construction joints in low seismic regions. Although there is no specific requirement for this in the IRC, we confirmed that this requirement aligns with ACI 332, PCA 100, and the assumptions built into the IRC. As you can see, this provision is now much more specific than the prior amendment. It provides a keyway width and depth dimension and location requirement, and also provides an option to use the vertical bar with standard hook at 48 inches on center option in accordance with Section R403.1.3.1, which is the requirement for high seismic regions. Or the applicant can propose any other lateral restraint option for your review and approval. Again, this is consistent with meeting the model code intent and assumption that foundation walls are laterally restrained at their top and bottom. The Code Advisory Committee recommended leaping ahead to the 2024 IRC in this section, which replaces the continuous footing requirements in high seismic language with a new table. The intent of this change was to provide clarity to what was deemed confusing and at times misapplied. Remember that the intent of this section is to prevent overloading the main floor diaphragm in high seismic regions by limiting its span. You now see that the charging requirement is for exterior walls and required interior brace wall panels of buildings in D0 through D2 are to be supported by continuous footings in accordance with the new table R403.1.2, in lieu of the confusing part of the provision which had an embedded exception followed by an additional exception. So now you can simply apply your project-specific variables to the table to quickly determine the requirement. There's no change to the application. It's just been changed to tabular format with a footnote for clarification and consistency. Some of you may have had a local policy on whether or not you allowed wet setting mud sill anchor bolts because the code didn't specifically address it. This model code change now allows wet setting them under certain conditions. Where the builder chooses to wet set the mud sill anchor bolts, the code requires that they vibrate the concrete if there is physical resistance or consolidation is hindered when they attempt to place them. As you can see, this is a risk that the contractor will be taking on and not subject to your foundation inspections if they choose to wet set. Note that this does not include proprietary anchorage products such as hold-down anchor bolts, which are required to be installed in accordance with the manufacturer's installation instructions.
Section R403.1.8. This change includes a new minimum tie requirement for grounding electrodes. The grounding electrode language that you see here on this slide is all blue because it's all existing Oregon amendment. And for clarity, only the new language is underlined. So the new language is in item 2, which further clarifies what tightly attached means. So now the code requires a minimum of 3 ties to the reinforcing bar. Section R406.2, Concrete and Masonry Foundation Waterproofing. The change in section R406.2 was made at the model code level. Items number 3 and 4 were deleted, and then the remainder were renumbered. 6 mil polyvinyl chloride and 6 mil polyethylene is no longer allowed for concrete and masonry foundation waterproofing. The reasoning given was that the 6 mil was too thin and it was getting damaged during backfill and was not providing adequate waterproofing. Section R408, underfloor space. This change is a reorganization for clarity. The underfloor space reorganization of section R408 includes a breakout of a long-running paragraph that is now broken into numbered sections to help clarity. It also clarifies that the 1 to 150 ventilation rate is only applicable in radon counties. The lower rate is allowed elsewhere because vapor barrier is required as a minimum. And also the language that was previously found and is still found in Appendix F was moved to this section as well that prohibits coverings over ventilation openings in radon areas. Section R506. This change retains the Oregon Amendment for 6 mil vapor retarders under concrete slabs. Along with the previous requirement that removed the 6 mil allowance for concrete walls and foundations, the model code also made a change to R506.2.3 that removed 6 mil polyethylene for under concrete slabs and replaced that with a minimum 10 mil that met ASTM E1745. Because the 10 mil was not readily available, especially meeting that ASTM standard, the governing board decided to stick with the language previously for 6 mil. So the 10 mil was not accepted, and the 6 mil still is allowed in Oregon.
There were quite a few changes that occurred in both the 2021 and 2024 IRC that expanded the prescriptive deck design options and provided further clarifications on existing provisions. The Code Advisory Committee recommended jumping ahead and pulling in provisions from the 2024 IRC to reduce the number of times stakeholders have to shift gears on learning these provisions. Remember that the prescriptive design provisions we're familiar with today are fairly recent. They were introduced into the 2012 IRC based on the provisions of the American Wood Council's DCA 6, which is their Design for Code Acceptance document for exterior decks. We currently link this publication as a resource on our residential code program page. Note that the American Wood Council is currently working on an update to this publication. Every code cycle since the 2012 IRC has seen expansion of the scope, cleanup, and clarifications throughout this section. We won't be going over every change that occurred in this section, but we'll do our best to highlight those that are impactful to you. With the exception of the deck footing table, the previous ground snow load limit for prescriptive deck design was 40 PSF. This was shown via footnotes in the prescriptive tables. Section R507.1 now requires that the deck be designed for the greater of the design live load of 40 PSF or the site-specific ground snow load up to a maximum of 70 PSF. Remember that Section R301.2.3 snow loads says that buildings in regions with ground snow loads greater than 70 PSF shall be designed in accordance with Section R301.1.3, non-prescriptive design. You'll see this expansion from 40 PSF to 70 PSF ground snow load limit in all of the prescriptive tables throughout this section. The wood materials subsection no longer mandates preservative-treated or naturally durable lumber, and instead only points to Section R317 for compliance. As Eric pointed out earlier, you have the exception to Item 8 of Section R317.1, which provides flexibility to use lumber other than naturally durable or preservative-treated where your local climate conditions allow. Although these changes are shown in blue underline here as an Oregon amendment, they are from the 2024 IRC. This will be the case for the remainder of the changes shown in Section R507 unless I note otherwise. As you can see, the deck post height table R507.4 has changed significantly. Previously, the height limit in the table was only a function of the post size specified. Now there are additional variables such as ground snow load up to 70 PSF, post species, and tributary area, which is consistent with the minimum footing size table you've become familiar with in the 2021 ORSC. Although I'm only showing part of the table here for simplicity, it takes up about 2 pages in the code because there's additional rows of different species for each loading scenario that includes southern pine, redwood, western cedars, ponderosa pine, and red pine posts. So now when you calculate the tributary area to each deck footing when doing your minimum footing size check using table R507.3, you can use that same tributary area calculated with table R507.4 to check the maximum post height. The deck beam span tables were reformatted, expanded, and revised in the 2021 IRC, as shown in pink here, and further changes were made during the 2024 IRC process, as shown in blue. Instead of just 2 rows for wood species, there are now 3, but note that I'm only showing 1 here for clarity. You can see that single-member 2x beam options have been added for all wood species, and the table has been expanded to capture various joist cantilever conditions. There are 4 different deck beam span tables depending on the loading condition. Table R507.5 parenthetical 1 is for 40 PSF live load, and tables R507.5 parenthetical 2 through 4 are for 50 through 70 PSF ground snow load respectively. Note that per footnote A, interpolation is only allowed where the deck joists do not have cantilevers. As you can see, the changes to these tables broadens the application of prescriptive deck framing and reduces overly conservative prescriptive designs from past code iterations. Although these tables have expanded, they are more seamless to use for design and plan review. Let's see what minimum size hem-fir beam would be needed for this example, assuming 70 PSF ground snow load. The deck joist span length is 14 feet with a 3-foot 6-inch cantilever span length, and the deck beam span length is 8 feet. Going back to table R507.5 parenthetical 4 and looking at the 14-foot joist span row and finding the associated column with the 3-foot 6-inch cantilever span length, we follow it down to the allowable span that's equal to or greater than our 8-foot span to determine the required beam size. For this example, we see a triple 2x12 hem-fir beam is acceptable. Consistent with the changes we saw for the deck posts and beam tables, the maximum deck joist span table has been expanded. It now includes up to 70 PSF ground snow load conditions and additional rows of different species for each loading scenario that includes southern pine, redwood, western cedars, ponderosa pine, and red pine, in addition to the Doug fir, hem fir, and spruce pine fir rows that I'm showing here. Also note that the allowable deck joist cantilever is now completely captured by this table instead of having to check the tabular value against the 1/4 the joist span value as was required in the 2021 ORSC. The 2021 ORSC had a footnote buried in the deck fastener and connector specifications table requiring the user to comply with the NDS for leg screw pre-drilling requirements to avoid splitting the deck ledger. This was definitely not helpful for users unfamiliar with the NDS. So the 2024 IRC struck that requirement and instead added specific pre-drilling requirements for the 1/2-inch diameter leg screws consistent with the NDS. The installer first needs to drill a 5/16 to 3/8 inch diameter hole through the ledger and all the way through the floor band joist. Then drill that hole to a 1/2-inch diameter just through the ledger and exterior wall sheathing. Consistent with the changes to the maximum deck joist span table, the deck ledger fastening table has been updated to provide required spacings for 1/2-inch leg screw or 1/2-inch through bolt connections for ground snow loads of 50, 60, and 70 PSF. As you can see, there was no change to the 40 PSF live load connection requirements, and I'm only showing the new spacings for the 70 PSF ground snow load here for clarity. Note that interpolation is permitted per footnote A. An important reminder regarding interpolation is that you can't assume it's allowed in prescriptive tables such as this. It's only allowed to be used where specifically permitted via table footnotes. Not all of the prescriptive tables in the code are linearly proportional. Some are based on exponential functions, where linear interpolation does not work and could result in a design that does not meet minimum code if misapplied. The last change to mention in section R507 is the added flashing detailing for the ledger attachment. You first see it here in the ledger attachment figure, where it now specifies the L or Z flashing under the decking against the exterior wall, and specifies that the WRB be lapped over that flashing for consistency with the minimum weather-resistant exterior wall envelope requirements in Chapter 7. The same added flashing detailing has been added to figure R50792 parenthetical 1, the through bolt with tension connectors option for an attached deck lateral restraint system. And it was also added to figure R50792 parenthetical 2, the other option shown in the code for a deemed to comply attached deck lateral restraint system. The base requirement for prescriptive stud size, height, and spacing is still per table 602.3 parenthetical 5, which limits their height to 10 feet. The only way to prescriptively allow studs taller than 10 feet is to comply with exceptions 2 or 3. The Code Advisory Committee recommended amending these exceptions to work with our minimum ground snow load of 36 PSF. The model code set an upper threshold of 25 PSF ground snow load for exception 2 and 30 PSF ground snow load for exception 3, so neither one could be applied outright in Oregon. During the 2017 ORSC update training, we explained how you could approve scenarios with ground snow loads greater than 25 PSF as long as the tributary load to the studs was within the intended code limit. And exception 3 was struck at the time as an Oregon amendment because the reference table couldn't be used with ground snow loads greater than 25 PSF. Now, exception 2 specifically allows Doug fir number 2 studs at 16 inches on center up to 18 feet in height or up to 20 feet in height when spaced at 12 inches on center, where the basic design wind speed is less than or equal to 130 miles an hour and supporting a roof only with max tributary load of 150 pounds per foot of site-specific ground snow load. So no change to how we informally interpreted this for the 2017 ORSC, but now it's codified for the 2023 ORSC. And the 30 PSF ground snow load limit in exception 3 has been changed to 36 PSF to allow use of table R 602.3 parenthetical 6, which is the alternate stud size, height, and spacing table. To make this table work with the 36 PSF ground snow load limit instead of the model code limit of 30 PSF, the maximum roof and floor spans in the table were reduced by 83% as an Oregon amendment. 83% of 36 PSF is 30 PSF, so the tributary snow load to these studs is the same for the 2023 ORSC as the model code. Something to be aware of during your plan reviews and inspections is that balloon-framed exterior studs around stairwells or tall studs at vaulted entries using this code path can result in seismic irregularities per section R301.2.2.6 and trigger non-prescriptive lateral designs for portions of the building. And also remember that where these tall wall provisions are utilized, such as balloon-framed gable end walls, qualifying brace wall panels are limited to 12 feet in height per section R 602.10. The prescriptive fastening schedule has received model code updates for alignment with the respective table in Chapter 23 of the IBC, and the typical roof sheathing attachment fastener spacing has been clarified and tightened to provide the necessary capacity to resist the associated component cladding wind uplift pressures. Item 1 has added roof rafter and roof truss blocking fastening provisions. Item 12 is just a relocation of the king stud to header fastening requirement that we saw buried in section R 602.75 of the 21 ORSC, with more fastener options now. And items 31 through 33 have been updated. Specific to roof sheathing up to 3/4 inch thick, note the significant change from 12-inch on-center fastener spacing at intermediate supports to 6 inches on center, and the requirement per footnote F to further tighten that spacing to 4 inches on center to gable end roof framing and intermediate supports within 4 feet of roof edges and ridges where the basic design wind speed is greater than 130 miles an hour in exposure B or greater than 110 miles an hour in exposure C. Since the roof sheathing nailing may not be easily observable during your inspections, you may want to consider noting it during plan review or as a courtesy, informing your general contractors and framers during inspections to make them aware of these new roof sheathing fastening requirements. There's also a significant related change in the alternate table to table R 602.3 parenthetical 1, which allows the use of staples to attach roof sheathing. In the 2021 ORSC, the tabular values listed could be used for roof sheathing attachments as long as the basic design wind speed was less than 130 miles per hour. But now the roof sheathing footnote G requires that the listed fasteners be installed at 3 inches on center at all edges and 3 inches on center at all intermediate supports, and only allowed where the basic design wind speed is less than or equal to 110 miles per hour. A minor Oregon amendment was made to Figure R 602.10.1.1 brace wall lines to address a common misapplication issue regarding the required extents of brace wall lines. All that was added to the figure is a dimension line showing the length of brace wall line A. Past code iterations required braced wall line lengths to be the worst case between the intersection with a perpendicular brace wall line or a perpendicular exterior wall. For instance, past iterations required that brace wall line A extend to brace wall line 1 for length determination. But per the past few code iterations, the length of brace wall line A is allowed to be measured from brace wall line 3 to the exterior corner of the building 4 feet from brace wall line 1, as now shown in the figure. The Code Advisory Committee recommended a change to the 900 square foot room exception in Table R 602.10.1.3 brace wall line spacing. The new language changes the wording of room to floor area enclosed by brace wall lines to allow more flexibility while still meeting the same model code intent, which is to allow this exception to go from 25-foot wall line spacing up to 35 feet one time on a project without having to adjust the required bracing per Table R 602.10.3 parenthetical 4. This row in this table is somewhat arbitrary and was a proposal that got pushed through at the national level by homebuilders lobbyists several iterations ago to address the regular occurrence of great rooms in today's homes. From a structural design perspective, the lateral force resisting system does not care or know where the interior partition walls are. So this amendment brought forward by the committee makes sense from a practical application perspective and aligns with the model code allowance. The term floor area used here is newly defined in Chapter 2 and used elsewhere in the code. A reminder is that this 900 square foot exception is not the only path to allow spacings of brace wall lines between 25 to 35 feet in high seismic. Instead, the last row here in this table is the default approach, which just requires that the seismic wall line spacing adjustment factor from Table R 602.10.3 parenthetical 4 be applied to the design. A new 10 foot from the end of a brace wall line exception in high seismic regions has been added to clarify the hold down requirements. It clarifies that the hold downs otherwise required for alternate brace walls, portal frames, and BVWSPs meets the intent of the hold down requirement we're familiar with in Exception 1. This change now codifies the informal interpretation we provided in response to questions on this in the past. Three-story dwellings in seismic design category D2 are now completely outside the prescriptive lateral provisions. Previously, Table R 602.10.3 parenthetical 3, bracing requirements based on seismic design category, allowed the user to utilize the prescriptive bracing provisions for the top floor and middle floor, but not the lowest floor of a three-story dwelling in seismic design category D2. Now those options are gone, and it's clarified that three-story dwellings in seismic design category D2 are required to be designed in accordance with Section R301.1.3 as a non-prescriptive design. Chapter 3 allows story heights up to 13 feet 7 inches now, which we went over earlier. And all of the heights shown in the condition column of this table are consistent with wall heights, not story heights. We pointed out the model code inconsistencies here to the International Code Council and found out they are providing further clarification in the 2024 IRC consistent with this amendment. And footnote G is new, which just reiterates the model code change we just talked about that clarifies three-story dwellings in seismic design category D2 require a non-prescriptive design in accordance with section R301.1.3. A new Oregon amendment in the wind and seismic adjustment factor tables changes the name of the story height adjustment factor to wall height adjustment factor for consistency with the rest of the code, and a new model code footnote has been added to clarify three-story requirements in seismic design category D2. We won't be looking at the specific changes in the wall bracing for dwellings with stone and masonry veneer in high seismic section, but just be aware that the whole section has been reformatted, reorganized, and clarified for consistent application of the provisions. Oregon amendments have been made to the prescriptive portal frame figures to clarify the header and continuous footing requirements elsewhere in the code, and to help minimize chance of misapplication. We've clarified that the minimum header size noted in the figure has to be checked against the minimum header size required by section R602.7 for gravity loading design. And we've modified the foundation portion of the figure to show the foundation wall reinforcement and updated the cross section to correctly show the continuous footing. Here's the update to the method PFG figure. Note that we reference the continuous exterior wall footing requirements per section R403.1 under the garage opening for clarification. And similarly, here are the updates to the CS portal frame figure.
Not a lot of substantive change noted for Chapter 7 of the code. However, here's a significant one regarding water-resistive barriers. At the model level, our long-standing R703.2 has expanded, adding additional prescriptive compliance options in place of the prior language, which included other approved products of equivalent performance. One reason for this change is that standard 15-pound tar paper is no longer the most common practice. Particularly in our state, higher efficacy WRBs are more commonplace due in part to our long-standing Oregon-specific drainage plane requirement of section R703.1.1. Here's the new provisions in R703.2. Prescriptively, WRBs can now be the old 15-pound D226 felt, ASTM 2556 Type 1 or Type 2, ASTM E331 compliant, ASTM E2273 compliant, or any other approved proprietary material in accordance with the MIIs and cut sheets. A couple of considerations here are the potential overlap with the drainage plane requirements of section R703.1.1, in particular, the exceptions to providing the 1/8-inch standoff between the WRB and the exterior wall covering or veneer, and the distinction of the two provisions. For example, if we are using 15-pound felt and we aren't providing pan-flashing details at all window and door openings, we must provide the 1/8-inch standoff between the exterior veneer and the WRB. It is important to remember that section R703.2 compliance is only one piece of meeting the charging R703.1.1 drainage plane provisions. The other major change in Chapter 7 is the introduction of a citable path for all soffits. These provisions are organized based on site design wind pressure, as we'll see on the following slides. Previously, there were no specific provisions regarding soffit material and soffit fastening in the code. In new section R704.1, we see the charging guidance of the new section. Where our wind pressure is 30 psf or less, we go to section R704.2. Where our wind pressure is greater than 30 psf, we use R704.3. How do we determine the wind pressure being referenced here? We refer back to our component and cladding tables using the following criteria. Walls with an effective wind area of 10 square feet, then adjusted for actual height and wind exposure category in table R301.2.1 parenthetical 2. Also, while specific to vinyl, we see attachment details for a single span and double span panel support in the two section figures. These subsections round out the rest of the soffit section. For wind pressure PSF of 30 or less, we see R7042 and then the associated subsection based on material. For wind pressure PSF of greater than 30, we see R704.3 and then the associated subsections according to the material used. In both cases, note that the prescriptive soffit materials are limited to vinyl, fiber cement or hardyboard, hardboard lumber, and wood structural panels, WSP, such as exterior plywood or oriented strand board, OSB. If the material proposed is not one of these, then the charging language guides us to use the manufacturer's written installation details, aka the MIIs or the cut sheets.
Appendix F, Radon Control Methods. The changes made to Appendix F were intended to align more closely with the EPA's nationally recognized standards for radon control. One of the first changes we find in Appendix F is to the definitions in AF 102.1. There are two new definitions added that correlate with the new language that we'll talk about on the next slide. One for a geotextile drain matting, which is similar to the picture you see to the right. And the other is a definition for what a soil gas collector is. And that is new terminology and some new provisions that will be added. And there are three options for what a soil gas collector is. It's gravel, perforated pipe, or the geotextile drain matting. And we'll talk more about that on the next slide. The primary change to Appendix F has to do with new provisions for soil gas collectors. So under the previous requirement for a passive gas collector system, a pipe had to be vented up through the roof and it just needed to have a T under the vapor barrier in the crawl space. There was no extension of the pipe. And this made it difficult for future expansion to an active system. So if the passive system isn't working and you have to add a fan, which there's a requirement for an electrical outlet in the attic for a future fan, then work had to be done in the crawl space to make that new active system effective. So now there are three different requirements. You can extend 10 feet of perforated pipe, 5 feet in each direction from the T. You can do a geotextile drain mat that we talked about on the last slide under definitions, or you can have a trench of gravel. But any of these three provide a longer area than just a T for the gas to be pulled out if an active fan is added later. Appendix H, deck, patio, or porch covers. This change aligns the title with changes that were made back in Chapter 1 and adds deck and porch to what was otherwise patio covers, and also adds some clarifying language. Several areas of Appendix H were affected by the clarifications and changes added. The first of which you can see in the scope is the addition of deck and porch. Just to clarify that it's a cover, whether it's over a deck, a patio, or a porch, it still applies. And the 200 square feet is not changed. And we did add the new definition of building area to this section. The definition, again, also expanded with deck and porch. the 1-story and the 12-foot mean roof height has not changed. What has changed here is just a clarification that the open or glazed walls in this definition are as prescribed in this appendix. And finally, in AH 103.1, added the term exterior to enclosure walls. There have been issues in this past year or so with the house being one of the walls and having patio or porch door openings and wanting that to be included. And so just clarifying that this is the exterior enclosure walls that we're talking about here.
To add to light straw clay and straw bale appendices, we now have a new appendix, Appendix U, addressing a more prescriptive approach for cob construction. This methodology is often referred to as Adobe and is common in some areas of the Southwest and Midwest. There are quite restrictive limits on seismic design categories, and the appendix still relies heavily on non-prescriptive design, as Jeremy from our team covered previously in this presentation. Often, local land use laws may further limit the potential for landowners to construct unique dwellings such as cob homes. Our team often receives customer inquiries regarding cob construction options, and we now have a related appendix detailing additional minimum requirements for customers to consider when evaluating the options for cob designs. "3D printed homes is a methodology that has become a trending option for increased housing production and increased density in areas of our nation. New subdivisions have been successfully constructed using 3D printed construction standards in Texas, Arizona, New Mexico, California, and there are even several current projects here in our state of Oregon. This new model appendix is short, relying heavily on R104.11 and the AM&M request path, but it does codify the UL 3401 standard, which outlines a performance compliance methodology for 3D printed homes. On the national level, the American Concrete Institute has pushed back on the UL 3401 standard and the likeness drawn to standard above-grade concrete construction. We anticipate seeing a significant amount of national adjustment in the 3D printed construction standards arena in the very near future. But for now, this appendix provides a codified path in the right direction when considering support of technological advancements in the way production-level housing is accomplished. Even if you don't anticipate reviewing any 3D printed dwellings in your area of service, you should check out the new appendix and related UL standard. It's a fascinating methodology that may have potential expansion in the future.
Congratulations! This completes the 2023 ORSC Code Update Training. Thank you for watching this presentation. Providing useful information to all of you is important to our team. If you have questions or comments, please contact our structural program. Their contact information is available on the division's website. You can also scan this QR code to get there.